Hey guys, my name is Jeel Patel, and today I'm going to be talking about the periodic table of elements. This is for class Chem 152, and my professor is Mr. Peter Hefner. So, the periodic table of elements. Before we start, we have to do an introduction. So, what is the periodic table of elements? Well, there are some questions. Have you guys ever wondered how things are made, such as gold, bar of gold, or mercury? And what gives an object its texture and color and shape? So, these are different kinds of textures and colors. But so, like gold is bright yellow, and mercury is silver color or dark gray. So the answer is found in one table, and that table is called the periodic table of elements. This is a sample photo of the periodic table of elements. It contains from hydrogen, which is the first element, to 118th element. What does a periodic table consist of? Well, it has groups and periods. There are 7 periods and 8 groups. Groups go from top to bottom, even though it's so one group, second group, third group, fourth group, fifth, sixth, seventh, and so on. And the periods are from top to bottom, so 1, 2, 3, 4, 5, 6, 7, and they go from left to right. So the first group, group 1A, is also known as the alkali metals, and this contains elements such as lithium, sodium, potassium, rubidium, cesium, and francium. These are highly reactive when they come in contact with a acid or some form of gas, and these are most likely to form a salt with when they're paired with group 7A elements. But we'll get to that further later. The second group is called the alkaline earth metals, and these elements are beryllium, magnesium, calcium, strontium, barium, and radium. These are very common elements found on Earth. Then we go to transition metals. Transition metals are also very common, and the good examples would be from gold, silver, zinc, copper, nickel, iron, chromium, etc. And then we get to the lanthanides and actinides. And these are very rare, but these are very, very reactive. Like, you can use these to make X-ray goggles and everything. Then there's metalloids. Metalloids are a form of metals and nonmetals, so they can be reactive or non-reactive. So some examples are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Then there's pnictogens, and they come in group 5A. 1, 2, 3, 4, 5. Group 5A consists of nitrogen, phosphorus, arsenic, antimony, bismuth, and macronium, something like that. And chalcogens. These are group 6A, and consists of oxygen, sulfur, selenium, tellurium, polonium, and livermorium. Then there is group 7A, which consists of fluorine, chlorine, bromine, iodine, acetine, and tennessine. And these are mostly gases. And the last group, also known as group AA, is known as noble gases, and these are all gases: helium, neon, argon, krypton, xenon, radon, etc., etc. Okay, so as you guys saw, that it has 118 elements, but each of them has their own, each the element is unique. So let's take carbon, for example, which was in group 5A, 4A, and it has a chemical symbol called C, the chemical name of carbon, their atomic mass in grams per mole, and atomic number of 6. Likewise, calcium has a symbol of Ca, the name, 40.08 grams per mole, and the atomic numbers is 20. And as we go to the right, this is also known as the electron configuration. So this is the nucleus of calcium. It has 20 protons and 20 electrons, if you count them, which is the same as the atomic number. So all the protons and electrons match the atomic number. So for mercury, there has to be 80 electrons and 80 protons in the middle. Helium would be a better example because you can count that there's first and second electron like the atomic number, and there should be 2 protons and 1 nucleus in the middle. Now, there are also some trends in the periodic table, and these trends include the atomic radius, melting point, electronegativity, and ionization energy. So, atomic radius, as you can see, that as we go down, the color gets brighter. That means the atomic radius is increasing, and as we go from left to right, the radius is decreasing. And electronegativity, as we go from top to bottom, it's decreasing, and we go from left to right, it's increasing. Same as ionization energy. So the atomic radius is, let's take hydrogen and cesium for example. They come in the same group, group 1A, and hydrogen has one electron. That means it has a smaller atomic radius, because look at the distance from here to here. While cesium has a larger atomic radius because it has a lot of electrons and protons. Electronegativity is a form of removing an electron or separating an electron or pulling it out so that atom can become fully stable. So fluorine, it's not going to be easy to remove this electron because the attractive pull from electron or proton is very strong. But think about francium, which is all the way in group 1A and group 2A, and the electron is very far away from the nucleus. So it'd be much easier to move this electron from the outer radius than fluorine on the inside. So fluorine has the highest electronegativity and francium has the lowest electronegativity. Fluorine has a smaller atomic radius and francium has a larger atomic radius. So this is the full periodic table of elements. It contains group 1A to groups AA, metals such as alkali earth metals, transition metals, metalloids, nonmetals, lanthanides, and actinides. These elements also have charges. So like I said, if you want to pull an electron, you're going to lose that electron to become fully stable. So lithium only wants 2 electrons on its outer shell. So it's going to lose that electron and get a charge of +1. While fluorine needs just 1 more electron to become fully stable like neon. So it's going to gain some electron and it's going to have a charge of -1. Carbon, on the other hand, has 4 electrons on the outer shell, like four valence electrons. So it's going to gain 4 or lose 4 to become fully stable. So the charges go from +1 to +2, +3, plus or -4, -3, -2, -1, 0. So you can see a pattern. You go from plus to minus. Sodium, like I said, sodium has 1 on the outside, it's going to lose 1. And chlorine has 7, so it's going to gain 1, become fully stable. So sodium atom and chloride atom, when they bond with each other, when they come in contact with each other, this sodium is going to share its electron with chlorine, so it's going to become an ion, and chloride is going to become an ion. And it's going to form a NaCl, which is a form of a salt. So what if we think about these same elements? Let's take 2 chlorine atoms, for example. These 2 chlorine atoms have 7 valence electrons each, and neither wants to give up its electron to the other, so only one can become stable. So what these chlorine atoms is going to do is they're going to come in contact with each other. So like they're going to come close to each other, and what they're going to do is that each chlorine atom will share its electron with the other. This way they'll share the electron, so both of them get 8 at the same time, and these will form a bond, which is chlorine-chlorine bond, which is going to be nonpolar because neither one of these chlorine atoms is going to try to pull the other electron towards itself because both have the same pull. This leads us into chemical reaction. Chemical reaction is 2 objects coming together forming a bond. So like chlorine and chlorine form a bond, sodium and chloride form a bond. So this red ball and the green ball will come in contact with each other and they'll form a combination reaction together. Decomposition is that these two marbles or balls will split into red and green. Single displacement is the partner will switch, so green will come with red and the blue will go alone. Double displacement is just partner switch, so red will come in with blue and green with pink. And when these reactions happen. Sometimes we make an acidic compound or a basic compound. Acids have a pH of 1 through 6, and bases have a pH from 8 through 14. And pH scale is just a measure of acidity of a compound. So if it has a pH lower than 7, it's acidic, and if it has a pH of 7, it's neutral, and if it has a pH of greater than 7, then it's going to be a basic compound. So some of the examples are hydrogen chloride. It has a pH of 8. It has a pH of between 1 through 3, and it's a very, very acidic. If it falls in your hand, you'll probably most likely burn your hand. Sodium hydroxide is very basic. So when these come in contact with each other, so let's add hydrogen chloride and sodium hydroxide in water. So what these will do is form another reaction, so double displacement. Hydrogen will come in contact with hydroxide ions and chlorine with sodium ions. So these will split and form NaCl, which is also known as salt and water. So this is also known as acid-base reaction, and when an acid is added to a base, it will form a salt and water, and the total pH will go from 2 and 12 to 0 and 7. So these are just going to form a neutral reaction. So the periodic table of elements is very useful. It doesn't just contain all the elements like platinum, gold, magnesium, sulfur, all these, but it contains a key to making compounds, and also tells us about the structure, stability, shape, texture, color of an object. Thank you for watching, guys. This is just it for the video. The usefulness of periodic table doesn't end here, but this is just it for the video. Thank you.